All right, guys, so this will be the first lesson of this week here, and it's going to be covering circles and arcs. So we're going to go ahead and jump into it. There's a little bit of notes here. So again, if at any point you need to pause the video, kind of look over some information there, feel free to, because again, this video is all for you guys. All right, if you have questions, feel free to email me, but there will be quite a bit of information here. So I understand if you need to pause or kind of rewind some things to go over it. All right, so let's jump to some key vocabulary here. Again, I did kind of bullet it here so you kind of focus on it. So in a plane, a circle is the set of all points equidistant from a given point called the center. Again, equidistant means equal distance from one another. That's what that means. All right, so a diameter is a segment that contains the center of a circle that has both endpoints on the center, on the circle. So a diameter has to go through the center and land. It's a straight line, and it has to have both endpoints on that line on the circle. So again, it's a straight line, has to go through the center where both endpoints end on the circle. A radius is a segment that has one endpoint on the center and the other endpoint on the circle. So again, the 2 points on that one are going to end on the center and on the circle. That's going to be our radius. All right, and congruent circles have congruent radii. I must have wrote that twice for some reason. I don't know what happened there. Congruent circles have congruent radii. So again, if circles are the same, that means the radius are going to be the same. A central angle is an angle whose vertex is the center of the circle. So again, a central angle starts from the center. And again, it's the angle between the 2 radii. That's all it is. Okay. So let's take a look here at a little more essential understanding. You can find the length of part of a circle circumference by relating it to an angle in the circle. An arc is a part of the circle. So again, the arcs are when I have 2 radiuses, and as part of the circle that connects those 2 radiuses, the arc is that part right there. One type of arc is called a semicircle, or also known as a half of a circle. A minor arc, so these are 2 kind of key arcs here. A minor arc is smaller than a semicircle. You name a minor arc by its endpoints, and then the other, if it's not a minor, then it's a major. A major arc or a semicircle by its endpoints and another point on the arc. So a minor is going to be smaller than a semicircle. I mean, it has to be smaller than 180 degrees. Okay. A major arc can be half of a circle. It can be half of a circle, but it can also be bigger than a semicircle as well. So a semicircle is half. The major arc has to be at least half, if not bigger. Okay. Again, we name minor arcs by 2 points, major arcs by 3 points. Semicircles fall in that same circle as a major arc. And again, use this picture here as a good example. Again, it's a little loop over those 2 endpoints. That's all they are. Okay. So with that now, let's try some problems here. So our first example is just naming arcs. That's all we're going to do first is just name them. So use the circle on the right to answer all the questions below. So what are the minor arcs here on circle O? Now, there are quite a few answers here. So one of the answers could be, okay, one of the minor arcs, again, it has to be smaller than 180. So again, if I can already tell there, I see a diameter from A to E. So again, that means that arc from A all the way to E there, that arc is a semicircle. So again, that is not a minor arc. It has to be smaller than that. Now, so an arc between A and E could be AC. So I'm going to write AC as a minor arc. Again, put that little arch there over those 2 endpoints. Okay. Now, also understand that you could write CA. AC and CA are the same thing. You don't have to write it twice. Okay. So again, AC is one minor arc. Another one could be CE. That's a big arc there. So CE is another minor arc. We also have ED. And then the last one would be AD. Now, again, the order of those do not matter. So if you put DA, that's not wrong. Okay. What are these semicircles of the circle O? So again, we're looking between 2 diameters. So if that's the case, those could be. Now, remember, since this is a semicircle, this also falls in the line of a major arc. All right. So there are multiple ways that we can write this here. So one arc could be, so again, we're going to use 3 points. So for minor, we use 2. For major, we use 3. Or semicircles, we use 3 as well. So one of those could be DAC. Again, with that DC being a semicircle, I have to have 3. Between that arc right there, A fell in between it. So that is one semicircle. Then I look from A to E. Again, from that one, I would say A, C, E is another semicircle. Continue working my way across. Then I have CED as another one. And if I keep working my way across here, then I have EDA. EDA. All right. Now, again, just like the minor arcs, those can be rewritten the other way as well. So you could have CAD, ECA, and so forth. But again, the endpoints have to be on the end of those. Okay. What are the major arcs of circle O that contain point A? So again, major arcs have to be bigger than 180 or equal to 180. So again, this one has to contain point A. So if that's the case, one of those could be, let's see here. So if it's bigger, let's start with A. Let's start on A and see what happens there. So if I start with A, the biggest angle I could get without making a full circle here would be ACD. So that means I go in the order from A all the way to C, then I end all the way with D. So that'd be arc ACD. That contains point A because point A is involved in that. You could also say CEA. So that means I go from C to E to A. So understand about this one here, guys, is CEA and CDA are the same thing. I just have to pick one of those points there. So again, if you said CDA, that's not wrong. CEA and CDA are the same thing. So understand that's talking about the same arc. Just know that with major arcs, you just have to pick one of the points. That's all. Okay. You could also have EDC. So again, go in order there. So when I say EDC here, if I start with E, then I go to D. I'm not cutting across that semicircle there. I'm always staying on the arc. So I go from E to D to C, which means A is still involved there. And there's one more. That one would be D, A, E. So in this instance here, E, D, A, or E, D, A, E would go from D to A all the way to E. So again, you are always moving around the arcs. You're never cutting across the circle. So just make sure you're careful about that. Okay. Key concepts here. Now we're getting into arc measure. So with arc measure, that is the measure of a minor arc is equal to the measure of its corresponding central angle here. The measure of a major arc is the measure of the related minor arc minus 360, which means the measure of a semicircle is 180. So knowing that the central angle right here on this example, so that central angle, since that's near the middle there, since S is our center point there, the central angle is 50. So knowing that is the central angle, that means the arc from R to T. So from that central angle to that arc, it's the same angle. So that means that the angle from RST is 50. Now, to find, let me write that here. So that means that this arc right here is also 50. Now, if they want us to find the arc of the major arc, which is this full part right here, so this full arc right there, they never gave us that part. I know that the distance around of a circle is going to equal 360. So to find that distance, we're going to do 360 minus the arc that we just found there of RT, which is 50. So 360 minus 50 gives us 310. So that's how we're going to find arc measures. Okay. Also, key note there, semicircle, 180. Okay, we got to remember that. Semicircle is 180, full circle is 360. Okay. All right. Arc addition postulates here. So adjacent arcs are arcs of the same circle that have exactly 1 point in common. You can add the measures of the adjacent arcs just as you can add the measures of the adjacent angles. So again, very simple there. So knowing that the arc of ABC is just going to equal the arc of AB plus the arc of BC. So you're just finding those two parts, adding them together to get the full arc. That's all it is. Okay. All right, example 2 here, finding the measures of the arcs here. So again, we are using this circle here for all of our questions here. So, all right, so our first step on letter A there, we're solving for the arc from B to C. So understand, knowing that this arc right here, this central angle right there is 32. Since it's a central angle, it's going to be the same as that arc there. That means since that central angle is 32, this arc is also going to be 32. Okay, which also gives us the answer to A there. So that means the arc from B to C equals 32 degrees. Okay. BD. So looking for BD now. Now, again, just like that arc addition postulate that we just talked about, I can add the two smaller parts together. So now that we have BC and now that we have CD there, my only step that I have to do here is add those two smaller parts together. So I would add 32 plus 58 to give me 90 degrees. That's 32 degrees. Okay. Next one was we are looking for ABC. So if I follow that arc, A to B to C, if I notice there's a line going through the center there, which means that is a diameter. So again, the diameter splits that circle into two semicircles. Again, we already talked about this. A semicircle here should equal 180. So that one's pretty easy for us. That's just going to be 180. And this one here, we're solving for AB. So now we're going to take this in reverse here. So knowing that ABC equals 180 and we're missing AB there, then again, all we're going to do here is just add those two parts together. X plus 32, set it equal to 180. So I would do X plus 32 because those two parts, when added together, should equal 180. So if I subtract 32, X should equal, when I work that out, 148 degrees. All right, not too bad. So again, a semicircle is 180 and a full circle equals 360. So again, we had to keep that in mind. All right, so circumference of a circle here. The circumference of a circle is pi times the diameter. So there are two ways that we can write this. It's either C equals pi d or C equals 2 pi r. So it all depends on what they give you. Do they give you a diameter or do they give you a radius? Again, you can use either one of those formulas there. So the number pi is irrational, so you cannot write it as a terminating or repeating decimal. To approximate pi, you can either use 3.14, 22 over 7, or you can actually use the pi key on your calculator, which is what I would recommend you use. Use the pi button on your calculator. For those that don't know, on your calculator, pi is right above the divide sign. So you would hit second, and then that little caret button right there, it's right above the divide sign. You hit that caret button there, and that should give you the pi symbol. Okay. Many properties of circles deal with ratios that stay the same no matter what size the circle is. This is because all circles are similar to each other. To see this, consider the circles at the right. There's a translation that the map circle O so that it shares the same center with circle P. There also exists a dilation with scale factor K over H. That maps circle O to circle P. A translation followed by a dilation is a similarity transformation. Because the similarity transformation maps circle O to circle P, the two circles are similar. So coplanar circles that have the same center are going to be called concentric circles. Concentric circles. Okay. Again, if they share the same radius, then we can just draw them on top of each other. So again, the smaller circle is going to be on the inside, and that'll give us the radius here. So let's look at an example of concentric circles here. All right. So a 2-foot wide circular track for a camera dolly is set up for a movie scene here. So the two rails of the track form concentric circles. The radius of the inner is 8 feet. And how much further does a wheel on the outer rail travel than a wheel on the inner rail track in one turn? So So let's look at the circumference of the inner circle, and then let's look for the circumference on the outer circle. Again, understand what circumference means. Circumference is essentially perimeter for any circle. So again, we don't have perimeter, so we call that circumference. It's essentially what it comes down to be. So I have an extra slide here. But again, understand that this center right here, that radius goes to the outer edge there. So again, to find, that goes to the inner circle. So that 8 goes to the inner circle there. So if that's the case, since that goes to the inner one, we're going to solve for that circumference first. So to find that circumference, since they gave us a radius, we're going to use the formula of 2 pi r. Either use 2 pi r or pi d, depending on what they gave you. They gave us the radius here. That radius is 8. So 2 pi r, and r we're going to write 8. So we're going to write that as 2 times 8, which equals 16 pi. Now remember, this is for the smaller ones. I'm going to put an S there to kind of remind us that's the smaller circle. Now if I go back, they told us that there is, what is it here? A 2 foot wide difference here from the rails. So if that's the case, if there's 2 difference and 8 was the radius for the smaller one, that means the radius for the bigger circle should be 8 plus 2, which is 10. So to find the bigger one, I'm going to put a B here for the bigger one. Again, they gave us the radius, so C is going to be 2 pi r, where your r should be 10. So that should be 20 pi. So all we're going to do from here, guys, is just subtract this part here. So 20 pi minus 16 pi. So again, it's just like using x. 20x minus 16x. I can subtract those two terms. So since I can do the same thing with those pi's there. So 20 pi minus 16 pi should give us 4 pi. So again, it depends on what they're asking you to solve it in, all right? So if they say to leave it in terms of pi, this would be your final answer. If they say to round it to the nearest 10th, 100th, whatever it is, then you would just literally type in your calculator 4 pi. And again, if they ask you to round it there, then your answer should come out to be right around 12.6. Again, that's if you typed in 4 pi into your calculator. So just understand, you could write it either way. Just see how they have it written on the question there. Okay, leave it in terms of pi or round to the nearest 10th, whatever it may be. Okay. All right. Arc length. Arc length. So the length of an arc of a circle is the product of the ratio. So it's always going to be the measure of the arc over 360. So it's the part over the whole. Always remember that. Part over whole, and the circumference of the circle. So to find the length, again, part over whole times circumference. That's all it is. Part over whole times circumference. So let's take a look here. All right. So what is the length of each arc shown in red? So that means on letter A, we're solving for this part here. I'm going to put an X there. And on letter B, we're solving for this part here, just so that it's a little bit easier to see. Okay, if that's the case, all right, so then that means we need to find the part that we're looking for here. So knowing that this angle right there is 90, that means that arc of XY is going to be 90 degrees. Okay, so again, the first part that in that arc formula that we just saw is going to be part over whole. So the part that we're focusing on there is that 90. So it's going to be 90 over 360 times the circumference here. So we have to ask ourselves, did they give us the diameter or did they give us the radius? So if I look on that picture there, they gave us the diameter there. The diameter is 16. So that means I'm going to multiply it times pi d, which is just going to be 16 pi. So they already gave us the arc on this one here on letter B. So again, part over whole is going to be 240 over the whole part, which is 360, times this one. They gave us the radius there. So if they gave us the radius, we use 2 pi r. So in this instance here, I would use 2 pi 15. Okay. Again, multiply 2 times 15, which would give us 30 pi. So that's going to be 30 pi. And all we have to do here, guys, is just type this into our calculator here. Okay. So 90 over 360 does reduce down. So again, if I cancel those zeros out, that would give me 9 over 36, which is 1 over 4 times 16 pi over 1. So 16 pi over 4 reduces down to 4 pi. Okay, so 24 over 36 reduces down to, what is that? Divide by 12. That'd give me 2/3 times 30 pi over 1. So I'm left with 60 pi over 3. 60 divided by 3 is just going to end up being 20. So again, when you get your final answer, go back and see, is it in terms of pi or do they want us to round? And this one they said leave in terms of pi. So again, your answers would be 4 pi and 20 pi. But again, if they said round to the 10th, just type it into your calculator and round to the nearest 10th. So again, you could see both ways, just kind of a forewarning. Okay. All right, so that's the end of our lesson, guys. Again, I know it's a lot of vocabulary, but again, there's just a bunch of equations that you have to use. So again, if you have to go back to the video, go back, use those equations. All right, I try to simplify as best as I can, but again, if you need help, come to my virtual office hours. I have all the links in my LMS. Again, make sure you ask those questions. I'm here to help you guys. Again, stay as long as you want, pop in and out if you need to, but I'm here for you guys, okay? So again, come to those office hours. Again, if you have any other urgent questions, email me. I'll get back to you as quick as I can. Other than that, guys, stay safe, keep up with the work, and again, I'm here if you need me.